All right, guys, let's go. This is my second review. Okay, if you've been following, we've had one review. This is the second one on organic chemistry. We're doing this, so your exam will be the blast. So let's go. Taking this second question, and we'll read through the questions and find suitable answers for these questions. Two different alcohols can be produced from alkane B by an addition reaction. Okay, so look at this. Alkane B has been provided. Okay, we can make two different alcohols from this, and we are doing this by addition reaction. In addition reaction, we basically add substances. We add substances, and those substances act on the double bond, okay, to break it. So we are converting an unsaturated substance, which is this alkene, want to make it become saturated. Okay, as soon as we do addition reaction on an alkene, we convert the alkene to an alkane. So the unsaturated nature becomes saturated. All right, we're adding substances to make it become an alcohol. All right, so what do we do? To add the substance added, okay, to make alkenes become alcohol is water. So we're adding H2O to this. All right, but this water should be in the presence of phosphoric acid. All right, so we're doing this with concentrated phosphoric acid and a bit of heat. Okay, those are the reaction conditions. Okay, we'll get to those answers later. Okay, but firstly, once water dissociates, water actually forms the OH and the H plus ion. So the OH minus and the H plus ion. All right, so if we add water into our phosphoric acid, water splits into hydroxide ion and hydrogen ion. So those two substances can actually break the double bond right here for the alkene, and it can make the unsaturated nature of the alkene become saturated. That means we can change the double bond to a single bond. So we can get two structures for this, and those two structures will be the two alcohols for this question. So let's go. Let's start with the first carbon and the second carbon. Remember, we are breaking the double bond to become a single bond. Let's make this a linear structure. Start from the right. This is CH3 right here, so put your 3 hydrogen atoms. All right, so let's go with the 3 hydrogen atoms right here from the right. We've broken the double bond here, so this carbon atom has 1 hydrogen here. Let's put that hydrogen. And this one has 2 hydrogen atoms attached, so let's bring in those 2 hydrogen atoms, okay, that were initially attached. Now, the OH and the H plus, okay, we can bring in our OH right here and bring in our H. Okay, so this is the first structure. This substance is actually propanol, okay, with the OH on the first carbon. All right, so that's propanol. We can get a different structure actually, because we're expected to get two structures for this. Let's redraw. Okay, so this is the first structure. Let's redraw. Still 3 carbon atoms, double bond also broken, but this time let's still fill our hydrogen atoms. Fill the hydrogen atoms from the right. Okay, bring in the H and the H and the H also. Okay, so now we're bringing in water from here, the OH and the H. Okay, so this time let's bring the OH to the middle. Okay, and put the H on this side. Okay, so it's a different structure from the first one. Okay, so the first we had propanol or propan 1 all, because the OH, okay, was placed on carbon 1. Okay, but in this second scenario, we have propan 2 all, because this time the OH has been placed on carbon 2. So these are the two structures we can get if we actually do addition reaction on this alkene B. All right, what are the reaction conditions and the reagents? Okay, from this equation we've written, see the reagents right here. The reagents, okay, it's actually water. Water right here, and we also added concentrated phosphoric acid. Okay, so concentrated phosphoric acid, H3PO4. Okay, very good. The condition here is that there must be heat. Okay, so that we write heat, or we can also take this as high temperature. We can make this high temperature. All right, reaction conditions for that, heat or high temperature. Let's take a second question. On this, alkene C can be converted into a polymer. Okay, for polymerization, basically we are looking at two types. It can either be an addition polymer or a condensation polymer. Okay, I'll quickly answer this question. In condensation polymerization, we are simply eliminating substances like water or ammonia. Okay, if you look at this substance right here, we can't get water from this or ammonia, so simply this will be addition polymer. So the type of polymerization that occurs here is addition polymerization. Okay, whenever we're dealing with alkenes like this, we basically do addition polymerization. So just the name of the polymer formed. Okay, simply this substance has 4 carbon atoms. Okay, so it is butene. Substance is butene, so the polymer is polybutene. So we can either write polybutene or polybut1ene. Okay, the next question, we're supposed to convert this into a polymer. So to convert this substance into a polymer, see what you do. Take the part of the polymer, okay, that has a double bond, write that out first. So remove the double bond if you are writing that out. Okay, so we've written the first 2 carbon atoms. So the first 2 carbon atoms from this part. Okay, the first carbon atom has H and H on it. Okay, so bring those 2 atoms right there, H and H. The second carbon has H and CH2, CH3 on it. So let's bring that also right here. So this one has CH2 and CH3 on it. All right. We can simply put N to show that it is not just one substance. So that is the polymer. Okay. The substance is polybutene, and that's the structure of the polymer. Okay, for the last question here, we're looking at the empirical formula, okay, of the polymer. Empirical formula is the simplest formula. Okay, so what is the simplest formula we can get for this substance? For a polymer, we need to have a substance at least to show that it was formed from a double bond. Okay, so to break this into 2, we can actually get the simplest formula as C2H4. All right, for the polymer here, the empirical formula is C2H4. Okay, we'll continue with this series. This is just the beginning. Catch me in the next series.